Welcome again to another lesson with Mr. Canet. So our culmination of our Chapter 7 lesson, which we've learned how to combine like terms and use the distributive property, is all about factoring. And don't worry, factoring is not too hard. It's just going to be our distributive property being used backwards. So go ahead and pause here. Copy down what you see. But on this right side here where it says factoring, please make sure that you are leaving space here after these little bullet points, because I'm going to add some information into some of these spots. So leave space there, pause, and go ahead and copy down what you see. All right, welcome back, students. So our essential question today is, how do we factor a linear expression? And this whole focus is about factoring linear expressions. So first off, factoring is the inverse of simplifying. And remember, inverse just means if you thought I was going to give you the answer, go look in your vocab. What does inverse mean? And don't assume what it means. Go know what it means if you didn't know. But we're going to do simplifying backwards. That's inverse. So we use the distributive property backwards. So I'm going to have us start with our distributive property. So what the distributive property looks like was this. We had some term A on the outside that we brought to the inside and made this thing AB plus AC. This is forward. We're going to use the distributive property backwards, though. So we're going to start from this right side. So what we're doing in the process of factoring is we're looking for what the terms have in common. And you see these two terms have an A. They both have an A. So what we're actually going to do is we're going to take these A's and we're going to put them back in front of the parenthesis and remove them from the terms that were already there. We divide out that A. So forward distributive property, we multiply. Backwards of the distributive property, which is called factoring, is where we're going to divide with the GCF. So this whole lesson is focused on greatest common factor and also finding quotients, answer to division problems. So let's just start with the GCF. We're going to find the GCF of a couple monomials. Don't worry about the vocab of monomial if that's throwing you off. It's just a single term. We're going to find the GCF of these problems. So go ahead and copy down what you see. And again, leave space. We're going to pull out the things they have in common. We're going to get some answers. Go ahead and pause. All right, welcome back. Okay, so number one, what number do 4x and 12x have in common? Let's start with just the number. 4 and 12. What do 4 and 12 have in common? Yeah, you're right. It's a 4. Okay, and it's 4. The only thing they have in common is that the thing they both have. No, you're right. They also both have an x. So the GCF of 4x and 12x is 4x. So all we're doing right now is we're working on the pre-skill for factoring, which is being able to find a greatest common factor. So if you're having trouble and our problems coming up here, your issue may actually be you're having trouble finding the greatest common factor. And the skill I like to think this of is like 15 over 25. It's like simplifying a fraction. What number do 15 and 25 both have in common that you could divide them both by and end up with an integer? That's what factoring is here. All right, so let's go on to number 2. What number do 18a and 20ab have in common? You're right, they both have a 2 in common. And yeah, I almost forgot a letter. They have an A in common too. So we could divide both of these terms by 2 and A, and we wouldn't end up with a fraction. So let's look at number 3. What number do negative 25xy and 15y have in common? Well, we can remove a 5 from both of them, and we can also remove a y from both of them. So their GCF is 5y. Number 4. Skills don't change now that we have 3 things to look at. We're just looking for the greatest common factor of 3 things then. I could put 4 things here, and then we would just be looking for the GCF of all 4 things. So what number do 42, 14, and 7 all have in common? 7. Do they have any letters in common? Yeah, you're right. N. So the GCF of these 3 terms is 7n. So let's go on and see how this will actually be applied with our distributive property. So we're about to learn how to factor a linear expression using these 3 steps, which are actually just the steps of the distributive property backwards. So we'll pause here, copy down what you see. Okay, welcome back. So step 1, find the GCF. Well, what is the GCF of 4x and 28? What can we divide both these terms by? Yeah, it's a 4. Their GCF is 4. Okay, so we found the GCF. I wrote it down. Step 2, write the GCF on outside of parentheses. And that's because whenever we were distributing, our goal is to get rid of parentheses. When you're factoring, your goal is to get the parentheses to reappear. And we're going to leave space because we have 2 terms that are going there. Step 3, divide all the terms by the GCF and then write their quotients on the inside of the parentheses. So what is 4x divided by 4 get you? Yeah, you're right. That gets you an x. So the x goes on the inside. But that wouldn't be fair if we just did one term. We have to do the second term. The plus comes down. And what is 28 divided by 4? Yeah, you're right. That's a 7. We just factored these 2 terms. The factored answer here is 4 parentheses x plus 7. We know we have the right answer because if you were to do the distributive property back forwards, you would end up with the part we had first. Yep, so we did it all correct. And that's how you can check your answer before you actually are assuming you're done. So let's keep on going here. Okay, so we have a couple problems to try here. We're going to do 1 and 2 together, and then we're going to do 3 and 4 together in class. So make sure to leave room. I will make you recopy this if you don't leave room. So pause right here and copy down what you see. Okay, welcome back. Let's do number 1. Step 1, find the GCF. Well, what's the GCF of 3x plus 9? What number can we divide both these terms by? Yeah, you're right. It's a 3. Then we're going to have some parentheses because we're using the distributive property backwards. 3x divided by 3 is x, and 9 divided by 3 is 3. So our factored expression is 3 parentheses x plus 3. Number 2, what number do 12 and 7 have in common? The only number they have in common is the number 1. So can we factor 12x plus 7? Is it even possible? No, which means the answer to this problem is 12x plus 7. It is not factorable. We can't pull anything out because they had nothing in common. Go ahead and copy 3 and 4. Leave space. We're going to do these. 4, put a star next to number 4 because that's going to be an example of removing a negative GCF. Okay, we got one more slide. I'm going to ask you to copy down. Oh, it says question 4 there. I should probably make that correct. We're going to make that question 5. But copy down question 5 here. And I'm actually going to show you how to do this one in class because it is a little complex and it's going to deal with us using our area formula and what we know about area. Okay, so copy down what you see. That's our lesson today on factoring. Most of the problems are going to look like our terms here of 1, 2, 3, and 4, but the harder problem is question 5, and I'm going to do that in class with you to help you through that. I hope you understood everything, and if you didn't, please write your questions down in the question column and ask them in class. That helps guide me to help know what you understand and what you don't. Okay, I'll see you soon, students.